Hello, I'm your guide, Diane Williams, your guide to learning all about C programming. Today, we're going to talk about selection statements. We're actually going to start writing statements in our programs that allow our programs to make a decision based on certain criteria. So let's take a look at how we're going to do that. First of all, we're going to break the lecture down into talking about logical expressions. So we need to learn some new C operators. Relational operators, equality operators, and logical operators. We'll learn those, and then we'll move on to the actual C programming statements, the if, else, and switch statements that control the decisions our programs make. In the last part of the lecture, we will touch on the go-to statement and how it is not a good statement to use. Let's take a look now at the logical expressions we'll be using. Well, we're going to use relational operators for greater than, less than, greater than or equal to, less than or equal to. Remember, relational operators strictly compare two values. They'll result in an expression that is a value of 1 for true. So true expressions evaluate to the number 1, as shown here. False expressions evaluate to the number 0. So here's the C operator, the familiar less than sign. If we were to, for example, type these two constants and compare 3 less than 5, well, we know that 3 is less than 5. That result is true. And remember, in C, anything that evaluates to true evaluates to 1. So we equate 1 with true. The greater than symbol is shown here on the left. That operator, then, if we were to say 7 greater than 9, we know that 7 is not greater than 9. This expression is false. C evaluates that to the number 0, because we want to remember that everything in C programming evaluates to a numerical expression. Here's the operator for less than or equal to. It is important that the less than sign come before the equal to symbol with no spaces separating them. And you can remember that if you remember less than or equal to. You say it like that, less than or equal to, that's the same order as the operators. Right? So once again, if we were to compare 100 less than or equal to 100, we know that is true, and this expression will evaluate to 1 in C. And greater than or equal to, there's a comparison there. Well, 50 is not greater than or equal to 100. It's false. We're going to have a result of 0. And in just a moment, I'll show you a program that will run to see these results of 0 and 1. Let's talk about order of evaluation. Typically, we just compare two values. Normally, we just want to compare x less than y. This example serves the purpose of illustrating that everything is evaluated from left to right. So these relational operators are the same level of precedence. It will evaluate the comparison from left to right. But we could write this with parentheses around it as shown here as x less than y. This expression is evaluated first. And remember, this expression is going to result in a 0 or a 1. And we would then be comparing a 0 or a 1 to less than z. That expression will be evaluated. And what you should learn in C programming is that you really never want to write an expression with 3 comparisons like this. It's usually not the logic you want. Mathematically, we sometimes write something like this when we want to know if x is less than y and x is also less than z. But we'll see we have a logical AND operator that will handle this for us. I just use this example once again to illustrate that things will evaluate from left to right. If you write expressions like this, you may not get the results you expect, because you have to remember that this expression is evaluated. It will evaluate to a 0 or a 1, and then compare that 0 or 1 value to z. Okay, other things that we don't do, we cannot compare strings to strings. So remember, a string is literally a string of characters, or characters all grouped together here inside the double quotes. Here inside these double quotes is another string, goodbye. C does not know what to do if you say is hello less than goodbye. And what meaning does that really have? We normally don't do those types of comparisons. Later, we will learn how to work with string libraries and use functions that can compare one string to another. We have to have a special function that we call in order to do that, but we do not use relational operators with strings. Okay, the other thing we can remember here too is that even though we can't compare a string. So remember, a string is signified by characters or literals inside double quotes. We can, shown down here, compare characters. Remember, a character just has single quotes around it. And we also remember that A is represented by the value 65 in memory, capital B is represented by the value of 66. So if we were to do a comparison in C and say, well, is A less than B, capital A less than capital B, that would be true because it evaluates 65 less than 66. That's true, and the result is 1. So remember, you can compare individual characters. And as arithmetic expressions, we can compare those as well. But let's take a look down here. If we write x plus z greater than or equal to y plus x, it will actually evaluate this numerical expression first and then this numerical expression secondly before it does the comparison. And we're starting to talk once again about precedence. When we look in a precedence table, we'll see that addition has a higher level of precedence than these relational operators. Since that's the case, that's why this expression is evaluated and this expression is evaluated. And if we went ahead and took a look at the fact here we've got x equal to 5, y set equal to 6, and we stored z or 7 in z's memory, well then this expression x plus z is the same as 5 plus 7. That will evaluate to 12. The expression y plus x is the same as 6 plus 5. That evaluates to 11. And the final comparison is 12 greater than or equal to 11, which will be true. Okay. Now, let's take a look at the equality operators. When we want to see if two things are equal, we have to use two equal signs together. No space in between. Right? Remember, the single equal sign is the assignment statement. That assigns one value to another. In this case, we want to compare two things to see if they're equal. Double equal sign. Beginning programmers forget about this a lot. It's easy to do. We'll come back and see several examples where we use this, so you will get used to using this. When two items are equal to, we get a value of true, so this expression would return 1 here. Is 5 equal to 5? That's true. The result will evaluate to 1. Right? Is 5 equal to 6? That's false. So the result of this comparison is 0. Here's our not equal to. It's the exclamation mark followed by the equal sign. Right? When that's true, so in this case, 5 not equal to 6 is true. It'll evaluate to 1. 5 not equal to 5 is false because 5 is equal to 5. So we get a result of 0. All right, let's take a look then at example 1. And I'm just going to bring up code blocks. So with this lecture, there are several different examples in here posted on our class notes. All this code has been uploaded in our class website as well, so you can run it. Let me go ahead. So I just created a project and code blocks project environment called selection statements. I went ahead and opened several of these files, and the first one we're going to look at is the example1.c. This is not part of my project, as you can see here, so I can select this and right-click and say add this file to active project. All right, say OK here, and now we can see it's in our source file. All right, so what I've done is I've given you a program that's going to demonstrate that true expressions evaluate to 1 and false expressions evaluate to 0. So when we run this, we know the printfs are going to print out all these literal characters inside the double quotes. We'll see this at the top. And then we just want to show what the result of 4 greater than 4 is. So here's the expression, the comparison, 4 greater than 4. And that will result in an integer value of 0 or 1. That will be substituted into our placeholder right here, the %d. Remember, %d is a placeholder for an integer data type, and it will be base 10, d for decimal, base 10. So as we run this program, then we'll see what the value for 4 greater than 4 is, 4 less than 4, 4 less than or equal to, 4 not equal to 4, and 4 equal to 4. So let's just go ahead. I'm going to go ahead and do a build and run here. You should be doing the same with your copies of this, or even type it in and run it. You don't have a copy. So we can see now the result of 4 greater than 4. So this expression right here, let me highlight that. Let me bring the screen back up. 4 greater than 4, that evaluated to 0. It's false. 4 is not greater than 4. 4 is greater than or equal to 4. That's true. We get a 1. 4 is not less than 4. False. We get a 0. 4 less than or equal to 4. True. We get a 1. 4 not equal to 4 is a 0. And then 4 equal 4 is a 1. So true and false. I just wanted you to see that these expressions really do, the results of these comparisons really do evaluate to zeros and ones. We want to keep that in mind whenever we're working and see if you're using this, and if you're using these results somewhere, you need to remember the result is zeros or ones, how the C environment treats them. Okay, so let's just go back then here. All right. So I also gave you the example output of this program. If you're not able to run it at the time you're viewing this, you can compare what it does. All right. So here's just a summary then of the relational operators that we've examined. Right. The next section of the lecture will cover then logical types. One other thing, though, I do want to mention before we go into that is comparing mixed types. So in the other examples I just gave you, we just compared 2 integers, right? Well, you can't compare integers to floats, floats to doubles. You can't compare unlike types. It's always better to compare like data types than mixing up your data types. We will learn a technique called typecasting later so that we'll make sure we're comparing like types. But you can see here, if we were to compare 1 to 2.5, that would be true because 1 is less than 2.5 in this comparison. We have a result of 1. Now, I also gave you an example 2 program that's comparing floats to integers and asking you to say, well, what do you think the result is of this? So we could go back and run that in code blocks as well, or we can go ahead and take a look at the output here. So when we compare 4.0F, now what does the F mean after that? So let's go back up here. Here in the code, 4.0, if we write that all by itself, remember is of type double, I simply put an F here to make it a floating point type. So it's a float instead of a double. It does not affect the fact that the comparison, right? Even if we left this a double, we'd still get the same result. I just use the F in here to specifically make the types floating point or float. But we can see, right, that 4 is not greater than 4. That's false. 4 is equal to 4. That's true. And 4 is not less than 4. That is false as well. Remember, we have to be careful, though, with floating point because sometimes floating point can't perfectly represent a number. 4 is 2 squared. It is a power of 2, and we can't perfectly represent that just by typing in the constant in our floating point format. So there's no problems with that. But like I said, normally we compare floats to floats. A lot of times we avoid equality. We'll talk more about that later when we see how inaccurate floats are. All right. That ends this part of the lecture on relational operators. We'll come back in the next lecture and start talking about the logical operators.